Hello and welcome back to another AP3 video. And in today's video, we'll be going over SAT math questions, more specifically inferences from sample statistics and margin errors. We'll be going over easy, medium, and hard questions that appear on the SAT on this specific topic. So without further ado, let's get started. A city has 50 city council members. A reporter pulled a random sample of 20 city members and found that 6 of those polled supported a specific bill. Based on the sample, which of the following is the best estimate of the number of city council members in support of the bill? So let's digest all the information. So we have a total of 50 council members. So let me write that in yellow. So total of 50 members. And we're given that in the random sample, we're going to have a total of 20 city council members. So in a random sample, it's going to be 20 members. And then out of those 20 members, we're given, let me write that. And out of those 20 members, we're given that 6 of them supported a specific bill. So let me get green now. And out of those 20 members, 6 supported a specific bill. And we are looking for how many people, or what is the best estimate of the number of city council members and who supported the bill. So the total amount of members in the city, or the council members in the city. So how can we do to figure that out? What we can do to figure it out is divide 60 by 20 to understand the percentage of how many people support the bill, regardless how big the city council members are in the random sample, to figure out our answer. So what we can do, so let me do this in blue, we can do 6 divided by 20 to get the percentage of 30%. We can convert that to 0.3 as a decimal, and we're going to multiply the decimal by 50% to understand how many people supported a specific bill. And if we do that, we're going to do 0.3 times 50. We are going to get 15, and my answer is going to be C, supporting that specific bill. And we got that answer because regardless how big or small the random poll sample was, whether it's 30, 50, we're going to use that percentage and then multiply by 50 to understand how many people of the whole council supported that specific bill. So the answer is going to be C. Okay, let's look at this question. A random sample of 50 people from a town with a population of 14,878 were asked to name their favorite flavor of ice cream. If 7 in the sample named chocolate as their favorite ice cream flavor, about how many people in the town would expect to name chocolate? So let's go over all the information given. So we have a random sample of 50 people from the town. So the random sample has a total of 50 people. And we're also given, so let me write people right over here. We're also given, let me do it in red, that we have a total of 14,878 people with the population that were asked to name their favorite color or favorite flavor of ice cream. So in the total population of the town, so the total population of the town is going to be 14,878. And out of the random sample, 7, so let me do this in green, 7 were in the sample named chocolate as their favorite ice cream flavor. So out of the random sample of 50, 7 liked chocolate as favorite flavor. And it's important to write everything so you don't get confused in these type of questions to look for the answer. Okay, and we're looking for how many people in the town were expected to name the chocolate. So what we can do is do a little ratio to figure out how many people like chocolate in the population of 14,878. So you can do what we did in the previous problem. We can do, let me do this in yellow. We can do 7 divided by 50 to understand the percentage how many people like chocolate, and then equaling x, and then divided by 14,878 to look for my value of x. So what can I do? What I can do is divide 7 divided by 50 to look for my decimal, and it's going to equal 0.14 or 14%. So this equation is going to equal 0.14 equals x divided by 14,878. What I can do now is multiply the 14,878 on both sides So I get x for myself, and I'm ultimately going to get my answer for x. So, and when you plug it in into a calculator, you're gonna get the answer of 2,882. So x is gonna equal 2,882. We're rounding it. So let's say 83. We rounded it to the whole number because as a decimal it's 2,082.92. But if we round it up, it's gonna be 2,083. So this is our x value. Remember, this is an estimation, not exactly the actual. It's approximation. And we're looking for about how many people in the town will expect to name chocolate. Well, we just got to compare the answer choices, figure out which answer is closest to one that I got for x, solving the question. As we can see, the only one that can solve for that is going to be B. Okay, let's look at this question. A certain forest is 253 arcs. To estimate the number of trees in the forest, a ranger randomly selects 5 different 1-arc parcels in the forest and determines the number of trees in each parcel. The number of trees in the sample arcs are 51, 59, 45, 52, and 73. Based on the mean of the sample, which of the following contains the best estimate for the number of trees in the entire forest? So what can we do? Well, we can look for the mean of the sample, and that's going to be adding all the trees and dividing it by 5. Because like it says right here, a ranger selects 5 different 1-arc parcels in the forest and determines the number of trees in each parcel. So adding all the trees and divided by 5 is going to give me the mean of trees per parcel. So let's look at the numbers. I have 51, 45, 59, 52, and 73. And I want to combine all those numbers and divide it by 5 to look for the mean of trees in each parcel. So 51 plus 49 plus, 59, that is my mistake. Plus 59 plus 45 plus 52 plus 73. And then divide this whole thing by 5, and that's going to give you my mean. So we plug it into a calculator, because you can use a calculator, and if you can do it mentally, that is amazing as well. But using a calculator is going to be a lot quicker. And you're going to get the answer of 56 trees per arc, or parcel, sorry. So we have the mean. So how can I look for the total number of trees in the forest? Well, each forest has 253 arcs. And we just found the number of trees in the forest, or like an estimation of the mean. So what I want to do now is multiply the mean and then multiply by all the arcs to figure out my total value. So we're going to multiply 56 times 253, and that's going to give you the answer of 14,168 for the total number of trees in the forest. And we're trying to look for the ranges that align with the number of total number of trees in the intervals. So let's look at A. A is too small, so it's going to be incorrect, so let me do this in red. B is too small, and D is too big. Therefore, my answer is going to be C. Okay, for this question, you don't need to do math. You just need to understand to look for the answer using little bits of information or little key details to find your answer. So, a study was done on the weights of different types of fish in a pond. A random sample of fish were caught and marked in order to ensure that none were weighted more than once. The sample contained 150 largemouth bass, of which 3% weighted more than 2 pounds. Which of the following conclusions is best supported by the data? So we just got a random sample of fish were caught and marked in order to ensure that none of them were weighed more than once. And the sample contained 150 largemouth bass, and we're given that 30% of them weighted more than 2 pounds. And we're trying to look for which of the following answer choices will give us the best conclusion with the information given. So what can I do? So we got to make generalizations with the information given. We can use any information outside of it because we can't make a correct generalization. So let's compare answer choices A through D and figure out if it makes sense. The majority of all fish in the pond weighed less than 2 pounds. Well, let's look at the random sample. The random sample doesn't say all the fish. It specifically says largemouth bass. Therefore, A is incorrect because we're making a generalization of all the fish, but in the random sample, they're making a generalization of the weight of only the large batch fish, not any other type of species. So A is incorrect. Oops. A is going to be incorrect. Let's look at B. The average weight of all fish in the pond is approximately 2 pounds. Same problem with A, it's not specific enough, and we're talking about average, and that's the mean. And we can't find the mean because we're not given really any numbers to look for the mean, so B is also incorrect for 2 reasons. Let's look at C. Approximately 30% of all fish in the pond weigh more than 2 pounds. It's right that it says approximation because it's just an estimate, not exactly the actual value. However, it says again all fish in the pond, and it's only largemouth bass fish. Therefore, C is incorrect, making my only answer D. But let's make sure that it makes sense with the question. Approximately 30% of all large bass in the pond weigh more than 2 pounds. Well, it goes with the random sample of being large bass or a largemouth bass, and we can generalize it with all that specific type of fish in the pond, and it weighs more than 2 pounds, and 30% weighs more than 2 pounds. That makes sense with the information given. So it correlates with my question and my answer. So my answer is going to be D. Okay, we're going to go over a concept called margin error, and it's important for these very specific questions. So a park ranger asks a random sample of visitors how far they hiked during the visit. Based on the response, the estimated mean was found to be 4.5 miles. So it's the associated margin error 0.5 miles. Which of the following is the best conclusion from this data? So I'm given that the hikers had an average or estimated mean of 4.5 miles that they traveled hiking in the park, and we have a margin error of 0.5 miles. So what is margin error? Margin error is basically subtracting and adding the margin error, in this case 0.5, by the estimation mean, in this case, to look for my possible true value of the population that hiked during the visit, or how far they hiked during the visit. And that's important because we're given 2 ranges, so the smallest and the biggest number, to figure, and that there's going to be a range of the possible value how far they hiked, and it can be no more or less. So to look for a margin error, all I have to do is subtract 0.5 and subtract and add 0.5 to 4.5 to figure out my margin errors. And if we subtract 4.5 with 0.5, I'm going to get 4 as my possible smallest number, and then if I add 0.5 to 4.5, I'm going to get 5 as my highest number when it comes to my margin error. So let's look at our answer choices, A and B. It is likely that all visitors hiked between 4 and 5, and B, it is likely that most visitors hiked exactly for 4.5 miles. Well, the thing is that it is true that the visitors could have hiked 4 to 5 miles, but it doesn't be specific enough when it says, it doesn't mention anything about the estimated mean. So A is going to be incorrect because it doesn't talk about the possible mean, only talks about the traveling distance from 4 to 5 miles. B, it is likely that most visitors hiked exactly 4.5 miles. Well, we can't determine that because we were given ranges between 4 to 5. So the true possible value of the population can be any number between 4 and 5. So B is going to be incorrect. C, it is not possible that any visitor hiked less than 3 miles. Well, we want to use the information given to figure out and come with the best conclusion. So C is not necessarily wrong, but it doesn't go with the information given. So my answer is going to be D. And let's make sure that it makes sense. It is possible that the mean distance hiked for all visitors is between 4 to 5 miles. It mentions the mean distance, and it talks about it could be between 4 to 5, so my answer is going to be D. Okay, this is going to be the exact question that we did before, but we're going to do it with percentages. A sample consisting of 720 adults who own televisions was selected at random for a study. Based on a sample, it is estimated that 32% of all adults who own television use their televisions to watch nature shows, which an associated margin error of 3.41%. Which of the following is the most possible conclusion from about all adults who own television? So we're given that there's an estimated percentage of 32 that all adults who own televisions use their televisions to watch nature shows, and we're given a margin error of 3.14. So all I have to do for this question is just add and subtract 3.14 to look for my possible percentage true value of the adults that actually watch nature shows. So if I do 30, so let me do this in yellow. So if I do 32, if I do 32 plus 3.1 or 41, I'm going to get my value of 35 3.41, and that's going to be my highest value. And if I do 32 minus 3.41, I'm going to get my value of 28.59 as my smallest value. And we got to look for my best conclusion for the adults who own televisions. So here's a little trick for these type of questions. As we can see, only B shows us the margin error between 28.59% and 35.41%. A, C, and D don't mention anything about my margin error at all. A has a percentage, but it talks about more than 35.41% of all adults who own television use their television to watch nature shows. In fact, that is not true because my highest number can only be 35.41%. Anything greater is not going to be in my range. Therefore, A is incorrect, and C and D are incorrect because it doesn't even talk about my margin errors. So they're going to be correct. Therefore, my answer is going to be B, but let's make sure that's correct. Between 28.59% and 35.41% of all adults who own televisions use their television to watch nature shows. Well, it talks about my margin errors and my smallest and biggest value, and also talks about how it's could be the televisions to watch nature shows, the adults. So everything makes sense. So my answer is going to be B. Okay, let's look at this question. A store manager, reviewed the receipts from 20 customers who were selected at random from all the customers who made the purchases last Thursday. Of those selected, 20 receipts show that the customer had purchased fruit. If 1,500 customers made the purchases last Thursday, which of the following is the most appropriate conclusion? So I'm given that out of the 1,500 customers that were purchased last Thursday, they have a random sample of 80 customers who were selected at random. And out of those 80 people, 20 of them, the receipts show that they purchased the fruit. And we're looking for which of the following shows the appropriate conclusion. So here's the good thing about this type of question. Because it says appropriate, it's not going to be an exact answer. Well, therefore, I can cross out A and B because approximation is not the same thing as exactly. Exactly is a precise number. Approximation is kind of like an estimation. So my only possible answer is going to be C and D. Well, how can I look for my answer? Well, to figure out how many people purchased fruit from the random sample, I can do 20 divided by 4 to get a decimal or a percentage, and then multiply it by 1,500 to figure out how many people on Thursday ordered fruit. So if I do, let's do it in red. So if I do 20 divided by 80, I am going to get, and if I plug it into a calculator, I'm going to get 25% or 1/4. And this shows how many people in the random sample purchased fruit on Thursday. So I'm going to do 0.25 and then times 1,500 to figure out how many people on Thursday purchased fruit. So if I multiply that, I'm going to get 375. And this is going to represent amount of people buying fruit. Now let's look at our answer choices. As we can look, only D represents how many people buying fruit, or the best estimation of it being 375. C gives me 75, and that's incorrect. Therefore, my answer is going to be D. Okay, let's move on to the hard questions. In a study of cell phone use, 799 randomly selected U.S. teens were asked how often they talked on a cell phone and about their texting behavior. The data are summarized in the table above. Based on the data from the study, an estimate of the percent of U.S. teens who are heavy texters is 30%, and the associated margin error is 3%. Which of the following is the correct statement based on a given margin error? So remember, margin error is going to give us the possible true percentage of the heavy texters. So if I add and subtract 3%, I'm going to get my margin errors from my ranges of 27% through 33%. So this is going to be my interval of heavy texters and heavy texters only. So let's look at our answer choices to figure out if they make sense. Approximately 3% of teens in the study who are classified as heavy texters are not really heavy texters. So this is not in our range at all from 27 to 33. So that answer choices doesn't make sense at all because we can't determine 3% sectors are classified. It's very unlikely. It's possible, but it's very unlikely because the ranges goes from 27 to 33%. So A is going to be incorrect. Let's look at B. It is not possible that percentage of all teams who are heavy texters is less than 27%. Well, this is not in our range. It's possible, but it's very unlikely that it's going to be less than 27. So B is also going to be incorrect. The percent of all U.S. teams who are heavy texters is 33%. That's incorrect because, remember, we have a range of 27% to 33%. So it could be any numbers between those two ranges. So C is going to be incorrect. And let's make sure that D makes sense. It is doubtful that the percentage of all U.S. teams who are heavy texters is 35%. Well, it's not between our ranges. It makes sense that it cannot be 35% because our highest number is 33%. So it makes sense. Therefore, my answer is going to be D. Okay, let's look at this question. State X, Mr. Kemp's 8th grade class consisting of 26 students was surveyed, and 34.6 of the students reported that they had at least 2 siblings. The average 8th grade class size in the state is 26. If the state and Mr. Kemp's class are representatives of students in the state's 8th grade classes, and there are 1,800 8th grade classes in the state, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? So we're given that Mr. Camps has a total of 26 students that are getting surveyed, and out of those students, 34.6% of them are going to have at least 2 siblings. We're also given that every single class size in the state has an average of 26, and that in the state there's a total of 1,800 8th grade classes in the state. We're trying for which of the following best represents the amount of 8th graders that have fewer than 2 siblings. Well, because I have 34.6% representing the amount of 8th graders that have at least 2 siblings, the rest of the percentages will represent the 8th graders that don't have or has fewer than 2 siblings. So I can just do 100 minus 34.6, and that's going to equal 65.4%, or if we convert it into a decimal, we're going to get 0.654, and this is going to represent my percentage of 8th graders that have fewer than 2 siblings. So what can I do with this decimal point or percentage? Well, I can multiply that by 26 to represent how many 8th graders in a class are going to have fewer than 2 siblings. And if I multiply 0.654 multiplied by 26, if you plug it into a calculator, you're going to get an average, if rounded up to a whole number, of 17 students per class that have fewer than 2 siblings. So what can I do with the 17? Well, if every single class size in the state has an average of 26, I can make a generalization that in every single classroom in the state of state X, it's going to have 17 students that have fewer than 2 siblings. So I can multiply that by 1,800 to figure out how many 8th graders have fewer than 2 siblings. So now what I'm going to do is my 17 is do 17 multiplied by 1,800, and that ultimately is going to represent all the 8th graders in the state that have fewer than 2 siblings. So 1,700 times 1,800, or 17 times 1,800, sorry, is going to give us a value of 30,600 students that have fewer than 2 siblings. So my answer is going to be C. Let's look at this question. A researcher interviewed 411 randomly selected U.S. residents and asked about their views on the use of nuclear energy. The table above summarizes the responses of the interviews. If the population of the United States was 300 million when the survey was given, based on the sample data for the 411 U.S. residents, what is the best estimate in millions of the difference between the number of U.S. residents who somewhat favor or strongly favor the nuclear energy and the number of residents who somewhat oppose or strongly oppose to the views of nuclear energy? So we're given a lot of information. So let's digest a little bit. So this is a interview of 411 selected U.S. residents in the total sample of 300 million. And that's important because whatever 411 equals, like the decimal point, I'm going to multiply that 300 million to get my answer. But how can I look for my answer? Well, if we look at our answers, we can see that the best estimate in millions is going to be, so let me do this in red, based on the sample, the best estimate is going to be the difference between the U.S. residents who are somewhat favor or strongly favor of the nuclear energy, and subtracting that, and subtracting that by the number of those who are somewhat opposed or strongly opposed to it. So combine the ones that are favor and subtracted by ones opposed, and we're going to divide by 411 to figure out the best estimation, and then multiply it with 300 million, and that's going to give us our answer. So if we see somewhat favor, we're going to have 500 or 56 plus 214, and that's going to equal 270 people favoring it. And if we do the ones that are opposed, we are going to get 141. And if I do 270 minus 141, I'm going to get my answer of 129 from the difference between people that are somewhat favored and the people that are not favored. And that's important for this specific question. So what can I do now with the information given that it's 129? Well, what I can do with 129 is divided by 411 to figure out the difference between the somewhat favored and the ones that are favored and the ones that are not favored, so opposed. So if I do 129 and divide it by 411, if we round it up, so let's plug into a calculator, 129 divided by 411, we're going to get a decimal point. If we round it up to the hundreds or hundreds place, we're going to get a decimal point of 0.31. And this is going to represent the difference between people that are favor and the ones that are opposed. And with that decimal point, I'm going to multiply that by 300 million or 300 to get the best estimate in millions of the difference between people that favor and oppose it. So if I do the 0.31 and then times it by 300, if I round it up to my whole number, I am going to get a total of 94 million residents from the difference between people that are favor and oppose of nuclear energy. Therefore, my answer is going to be 94 million. And this is going to be the last question for today. So the table shows the results of the poll. A total of 803 voters selected at random were asked which candidate asked for the upcoming election. According to the poll, if 6,424 people vote in the election, but how many votes were in Angel Cruz be expected to win? So what can we do to figure it out? Well, what I like to do is figure out how big is the difference between 6,424 and 803 to figure out the ratio. So what I'm going to do is do 6,424 and divide it by 803. And if I plug that into my calculator, so 6,424 divided by 803, we're going to get a number or the ratio of 8. That basically means that the total voters selected at random, we just multiply by 8 to figure out the total value of the population of the election. So what I can do is multiply the amount of votes from Andrew Cruz and Terry Smith by 8 to figure out how many votes Andrew Cruz will be expected to win by the total population of the people that voted in the election. So multiply both by 8. If I do 483 times 8, I am going to get 3,864. And if I do 320 and then times 8, I am going to get 2,560. So to look for how many votes Andrew Cruz is expected to win, all I have to do now is just do 3,864 and then minus 2,560, and that's going to give me my answer. So 3,864 minus 2,560, that's going to equal 1,304. So my answer is going to be B. This is the last question for today. Thank you for watching.